Okay, more vocabulary today. This time the vocabulary is tied to some math. Okay there? Oh, and a highlighter might be a really good idea because there's a lot of things that we're going to look at in the picture. Might be an idea to highlight it. Wrong drawer. Okay. Central angles. So, definition of a central angle: an angle whose vertex is the center of the circle. So I'll use the little symbol there for circle. An angle whose vertex is the center of the circle. Central angle. We've got a lot of different angles that we can draw in these circles this time, and that's going to be part of this chapter, just learning all the different angles and how they're related mathematically. So, angle DEC is a central angle. Angle AEB is a central angle. Angle BEC is a central angle. Angle AED is a central angle. You can even combine a couple together. You could say angle BED if you wanted to, as long as it's less than 180 degrees, because all angles always have to be less than 180. So as long as we're looking at that, those are all central angles. Then there's some math to go with it too. If the central angle is 40 degrees, we can look at some other parts of the circle. If we look at the little notation down here, AC is perpendicular to BE. So if AC is perpendicular to BE, we also know how big that angle is. So we know angle AEB, another central angle, is 90 degrees. And what's AC? Question for tomorrow on the quiz. What's AC?
Diameter.
It's the diameter. How much does a diameter cut a circle into?
Half.
Cuts it in half. Whole circle is 360. So that means this much of the circle is 180 degrees. So if angle AEB is 90, then angle BEC is 90. And on this side's also 180 degrees then, isn't it? So if DEC is 40, then AED is 140. So we can find all those central angles. And again, as long as the angles are less than 180, central angles. A minor arc. Now this is one of the vocabulary words that will be on tomorrow's quiz, an arc. And we're going to talk about all different kinds of arcs here today. A minor arc is an arc whose measure is less than 180. So kind of matches the angle. As a matter of fact, if the central angle is 40 degrees, the arc that it cuts off, and we say cuts off because we're thinking that this ray comes out of the circle and this ray comes out of the circle. So it's like cutting a piece of pie. So if you cut that piece of pie out, if that's a 40-degree angle, then we say that this is a 40-degree arc. And we're really looking at the same thing where we were with angles. We're looking at the fact that the entire circle is 360 degrees around, and we're just cutting that circumference up into degrees. So we're just cutting the edge of the circle up into degrees instead of thinking about the angles in the center. So with a minor arc, central angle equals the minor arc. So central angle equals the arc. So we labeled all the angles in here for the central angles. Now we could label the degrees of all the arcs. Since this was a 90-degree central angle, arc AB is 90 degrees. There was another 90-degree central angle over here, so arc BC is 90 degrees. We can do the math the same way we did with the angles, and arc AD is 140 degrees. So the central angle equals the arc, same kind of thing. A major arc. A major arc would be something like this. And a major arc is greater than 180 degrees. So a minor arc is less than 180. Major arc is greater than 180 degrees. Now, we don't talk about angles over 180 degrees, but we do look at arcs that are that big. So again, since AC is the diameter, there's 180 degrees over here and another 40 here. So arc A, we could pick either letter. Let's say arc ABD, 180 plus 40 would be 220. Oh, and another thing, with a minor arc, when we're trying to write that, we just use like part of a curve for the symbol. So just like we did segment, that's the symbol for that. So if I was talking about arc DC, then I would write that little curve and DC. And arc DC was 40 degrees. So a minor arc uses 2 letters. A major arc uses 3 letters. Because if I only said arc AD, how would you know to go on this side or to go this way? So the only way that you know that it should be more than 180 degrees, because this would be less, is if I put that third letter in there. So that third letter, 3 letters, tells you it's more than 180 degrees. It's also basically like connect the dots directions. It says start at A, go through B and around to D. So if I'm starting here at A and I have to go through B, that means I have to go this direction. Then all the way around to D. If I just said AD, it would make more sense to start here and go this way. But by telling you ABD, that means I'm going that way around the circle. Okay? So minor arc, less than 180 degrees, 2 letters. Major arc, more than 180 degrees, 3 letters. Then we have a semicircle, and that is exactly 180 degrees. But the problem is, if I cut a circle in half, I have 2 sides, don't I? So if I just said arc AC, how would you know if I wanted this side or if I wanted this side? Yesterday I went into the teacher's lounge and one of the teachers in there had just microwaved a pizza. It smelled so good. Somebody said it must have been Maud's Pizza. Oh, it smelled so good. And it was about the size of a plate, whole pizza. And I thought, you know, teacher's my friend. I thought, she's not going to eat that whole pizza. It smelled so good. Well, I thought if she was nice, she'd offer. But she didn't. But if she had, she did have a pepperoni pizza. And I'm really not real keen on pepperoni. It's not one of my favorites. So if she had asked, I would have wanted this side of the pizza. So I would have told her then that I wanted arc ABC so that I got the piece that didn't have all the pepperonis on it. And she could have had arc ADC. And she didn't eat the whole pizza, but she also didn't offer it. So, okay, so semicircle, exactly 180 degrees, but we still need 3 letters because otherwise we wouldn't know which side of the circle to pick. Okay? No. Well, again, if I said A, B, C, then I'm telling you, go this way. This is the side that I want.
So it would be ADC if you wanted to?
Yeah, I could say ADC if I wanted that other side, but I don't. Okay? All right. Either way, they're both the same amount if you've actually cut it in half, but a diameter does cut it in half. Okay, so we said measure of minor arc is less than 180 degrees. Measure of major arc is greater than 180 degrees. And the arc, again, still equals the central angle. although we're not going to have central angles greater than 180 degrees. Adjacent arcs. Well, adjacent means next to. So adjacent arcs are just two arcs that aren't next to each other. So for instance, arc BC and arc CD are adjacent arcs. Arc BC and arc CD. And we can add adjacent arcs. So if I wanted to add these together, first of all, I could tell they were adjacent. They use the same letter. Then, back from our other picture again, we knew arc BC was 90 degrees. We know arc CD is 40 degrees. So if I added those together, my new arc then would be 130 degrees. So adjacent arcs are just next to each other, and we can add them together. You could add a couple minor arcs and get a major arc. So I could add arc BD and arc DA. That's okay. I could add those together and then get a major arc. Congruent circles. Well, just like all of our other stuff, our definition of congruent is same shape, same size. Well, all circles are the same shape. They're round, right? So all circles are the same shape. So how would we know if they were the same size? If they have the same radius, so if this circle had a radius of 3 and this had a radius of 3, then they would be congruent circles because they are the same size. Congruent arcs are just two arcs that have the same size. So then in this picture, because we said these were both 90 degrees, arc AB is congruent to arc BC. Now, the thing we have to be careful with is if we have circles that are not the same size, then we can't say the arcs in these circles are congruent. So let's take a pizza again and cut it into 4s. So maybe this one is that little individual pan pizza from Donato's. Donato's has those little individual pan pizzas. And this is that Costco pizza, that huge thing that you can get. I can't even close the oven door when I got one of those. Put the box in there. It's huge. Well, this is 90 degrees, and it's a fourth of that pizza. And this arc is 90 degrees. It's a fourth of that pizza. But I cannot say those are congruent because the two circles aren't the same size. I could say they were similar. They're the same shape. They're both a fourth of the pizza, but it's definitely not the same size. If somebody asked me which piece I wanted, I'd definitely take this one. It's bigger, right? So these are not. So if we say congruent, these are not congruent. Then, just to sum everything up, the measure of a minor arc is the measure of its central angle. So we said those were equal. The expression that is read as the measure of arc AB. We've had that before. We did that with angles, that little m, the measure of arc AB. The measure of the entire circle is 360 degrees. We know that. The measure of a major arc is the difference of 360 degrees and the measure of the related minor arc. And the measure of a semicircle is 180 degrees. So let's go back to this for a second. So let's say we were looking at major arc CAB. So arc CAB. And I wanted to figure out how big that was. I could add this arc, 40 degrees, this arc 140, this arc 90. I could do that, go all the way around the circle, and that's fine. Or I could just say, well, it's almost all the circle, everything but this 90, right? So then I could just take 360 minus 90 and get 270. And that's really just the quickest way around. Since a major arc is going to be more than half of the circle, a lot of times it's just easier to subtract out what you're not using, and then find the rest of the measure. Okay? All right, some postulates, theorems, whatever, I don't care. The arc addition postulate. So let's draw some radii in here. Let's say AB is 110 degrees and BC is 120 degrees. So the measure of arc ABC, again 3 letters, so that's a major arc, is the measure of arc AB, so that was 110, plus the measure of arc BC, and that was 120. So arc ABC then is just the 2 of them added together, or 230 degrees. So the measure of an arc formed by 2 adjacent arcs, so that's why we needed to know that word adjacent. The measure of an arc formed by 2 adjacent arcs is the sum of the measure of the 2 arcs. As long as they're connected, you can just add them together. Congruent circles. If 2 circles are congruent, or 2 circles are congruent, if and only if they have the same radius. And congruent central angles. In the same circle, or in congruent circles, 2 minor arcs are congruent if and only if their corresponding central angles are congruent. So in this circle, what kind of angles are those that they've highlighted? Vertical angles. So if this angle is 50 degrees, we know this angle is 50 degrees. So it says in the same circle, 2 minor arcs are congruent if their corresponding central angles are congruent. So we can say that arc BC is congruent to arc CD. Or if we have congruent circles like the 2 up here, if I knew that both of these had, I didn't draw those very well, if both of these had 60-degree central angles, then I would know that this arc was congruent to this one. I'm using 2 different circles, but I know that they are congruent circles. The one thing I cannot do, if this is a 50-degree angle, then this is a 50-degree angle. But I cannot say arc DE is congruent to arc WZ. Yes, they're both 50 degrees of the circle, but that's really more like a fraction or a part of the circle, not an actual size. So 50 degrees isn't a specific size. It's basically saying 50 degrees out of the whole 360. Well, this little teeny tiny circle can get cut up into 360 degrees. This big circle can get cut up into 360 degrees. That doesn't mean they're the same sizes. So just like the pizzas before with the 90 degrees in both of them. Sure, they're both 1/4 of a pizza, but if they're different size pizzas, they're not the same. So we cannot say arc DE is congruent to arc WZ, even though we would say they were both 50 degrees. Because we're really not saying an actual length. It's not a measurement. It's more of just a part. Okay, and then all circles are similar. Well, our definition for similar was same shape, different size, and yes, all circles are the same shape, but they are different sizes. What 4-sided figures are always similar? Always going to have the same shape. Squares. What 3-sided figures are always going to be similar? All triangles are similar? Equilateral triangles. And then if we get into polygons, as long as it's a regular polygon, whether it's a regular pentagon, or a hexagon, or a decagon, doesn't matter what kind of gon it is, as long as they're regular, regular means all the sides are equal in it and all the angles are equal. So those are always going to be similar. So all circles are similar, all squares are similar, all decagons, regular decagons are similar. They're all the same shape, they're just different sizes. Okay, so let's do a few practice problems. As a matter of fact, I'll give you a couple minutes to see if you can fill in 1 through 8 yourself, and then we'll check those. Perfect timing. Okay, so let's run through these first ones, finish the rest of this off. So it's the same picture we've been using. So again, 90 degrees here and here, 140 over here. So when they ask for arc AB was 90 degrees. Arc ABC, again, start at A, go through B, go to C. That was 180 degrees. Oh, yes, and they also said tell what kind of arc it was. So 90 degrees is a minor arc. 180 is a semicircle, 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 I don't care how you say it. Arc ABD, well, I think one of them they wanted to trick me, but we'll look. ABD, nope, that goes more than halfway around the circle, so 3 letters is a major arc. And now I just have to do the math. So 180 plus 40 would be 220. Arc BC, 90 degrees, again, another minor arc. Arc BAC, so this one is starting at B, going through A, and going all the way around to C. Well, this part was 180 degrees, plus another 90, so now we're looking at 270, and that's a major arc. Arc DAB, no, we're not dabbing right now. So that's going to be 140 plus 90, so that is 230.
I'll give you that one today.
Thank you. And again, major arc, 3 letters, more than 180 degrees. Arc AD is just over here. Minor arc, 140 degrees. And again, that's a little confusing because, well, let's finish this last one off. Arc CD, 40 degrees. With angles, we're used to obtuse and acute, that there's a difference between 140 and 40, but that's because 90 was where we had the difference between obtuse and acute. With minor and major arcs, 180 is the difference. It's got to be more than 180 to be a major arc. Less than 180 is still minor. So both of these are still minor arcs. Okay, in circle E, tell whether arc ABC is congruent to arc ADC. So ABC, well, that was a semicircle, 180 degrees. And ADC was just the other semicircle, the other side of the circle. So, yes, they were congruent. They had the same measure, and congruent arcs have the same measure. In circle K, and no, we're not going on a field trip. In circle K, find the measure of arc DE. So they want this arc. So I could look at this diameter, but that's not going to really do me any good, is it? So it's 180 on this side and 180 on this side, but that's not going to help. So what should I see in the picture? I could do that. I could do the 55-degree angle up here. That would help. And then when I look at this, I know one part. So 180 minus 55 is going to give me 125, and then that's the measure of that arc. So I could do that. Or I could have just used that diameter, and then I would have already known that was 55 and subtracted. So it's really just kind of up to you. What do you see first? If you saw the vertical angles first, that's fine, use them. If you saw this diameter instead and noticed that, that's good too. And then finally down here, find the measure of arc AB. Well, this time there is no diameter, is there? So we can't work with 180 degrees, so we're going to have to do the entire circle, so 360. So we've got 40 plus 70 plus 75 plus 2x plus 5x. The total equals 360. So again, it really just depends on what you notice in the picture. If you notice the diameter, you only had to subtract from 180. If there is no diameter, then you've got to do the whole thing 360. So 70 and 75 is 145, so that's 185 plus 7x equals 360. We'll subtract the 185. So 7x equals 15 minus 8 is 7. 175, isn't it? Divide by 7, and x is 25. Then, this question I like, because it didn't just say find x, it said find AB. So we'll have to come back over here. Arc AB was 5x, so 5 times 25 is 125. And that's your final answer. Okay, homework's basically the same thing. And as I said, you're going to be finished in 15, 20 minutes. So we're going to take some time at the end to go over some of the exam questions.